Hi everyone, this is Mike from Herbert-ABS with another Learning Series video. In this video, we'll do a quick overview of the Ship Squat tool in CargoMax, which can be used to get a rough estimate of how much a loaded ship will increase its draft, or squat, while going through a confined channel at a given speed. The faster the speed, the more the ship will squat, which could lead to the ship unexpectedly hitting the bottom of the channel. The tool is accessed through the Tools Ship Squat Entry menu item. And when you open the tool, the calculations will be based on the entered condition in CargoMax at that time. The Ship Squat viewer will appear as shown, with the graphic on the right, showing a representative cross-section of the ship and the channel dimensions, and the plot on the left showing the estimated squat across a range of speeds. The entry table on the lower left is where the squat calculator parameters are defined, and the table on the bottom right gives summary information. The first thing to note is that this calculation is a very rough estimate approach. Based on the empirical methods developed by C.B. Barras, which have been developed over years of analysis across a wide range of ship sizes and shapes, the CargoMax User's Manual gives more detail on the basis and parameters used. It is highly recommended to take all results provided by the squat tool in CargoMax with a high degree of caution, and they should not be solely used to confirm a potential voyage with tight restrictions. When using the squat tool, the first step is defining the dimensions of the channel. The key entries are water depth, the average depth to use for the channel. For this example, we'll use 20 meters. Is confined channel. If this is set to no, that means the channel width is wide enough to not impact the squat calculations. If this is set to yes, the subsequent channel width entry should be used. In this case, we'll select a confined channel with a width of 100 meters. Finally, the ship speed relative to water allows entry of the specific speed to check. In this case, we'll use 10 knots. We can see now on the results on the right side that the estimated squat at this speed is 1.33 meters. If we change the speed to 15 knots, the estimated squat changes and shows 3.09 meters now. The plot on the left shows the estimated squat as the speed changes. The green point shows the selected speed. The yellow point shows the speed at which the underkeel clearance is exceeded, and the red point shows the speed at which the bottom of the channel would be hit. The underkeel clearance can be defined in the bottom table, here. And if we change the minimum clearance to 3 meters, we can see the values update accordingly. On the right-hand side, I can now see that my speed where I would exceed the underkeel clearance limit would be 18 knots, and the grounding speed, or the speed at which the bottom of the hull would hit the channel, is 23 knots. If we hit OK on this tool with squat defined and go back into CargoMax, an additional alarm will show, showing the squat underkeel clearance. And the graphics will be updated to show the channel properties and clearance and squat outline as well. Finally, if we return back to the Ship Squat Entry tool, we can disable these by selecting the Disable Squat Calculation checkbox in the lower left corner and hitting OK. That will return CargoMax back to the original condition without squat. That's all for now. Thanks for watching. Thanks for watching this learning video. For more information, please visit us at www.herbert-abs.com or email us at info@herbert-abs.com.